Good morning, everyone. So, here is another beautiful day where we want to journey through C functions. So, what actually do we mean by functions, which we'll be looking at this morning to see what function is all about. And what we'll be covering, our agenda this morning is what are nested loops and how to use them. Nested loop and how to use them. What is a function and how do you use functions? What is the difference between a declaration and a definition of a function? Then what is a prototype? Scope of variables. What are the GCC flag or blah 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 all this? Then what are header files and how to use them? So we need to know what a function is. But actually, I think I can come up with nested loop and while loop. So let's quickly look at that since this is our first agenda on this list. So let's quickly look at that. Within 5 minutes, we should be able to cover that. So like I was saying, since the agenda is the first agenda is on nested loops before we move to functions. So let's quickly look at what nested loop is all about. So let's look at what nested loop is all about as this finish loading. Now, if before you could write your code, you have to declare your header file based on what you are calling, the function you are calling, which we know the common one is hash include stdio.h. Then you set your entry point, which is your main point. I'm not passing an argument, therefore I make it void. Then I open my my code block. Now I can decide to use while loop or for loop. While loop or for loop. Now there are certain situations where we use while loop and when we use for loop. But for loop and while loop actually are close related that they can still perform same operation, except in some cases. We use while loop when we don't actually know so like I'm saying that we use while loop when we don't know the number of repetition. While we use for loop when we know the number of repetition. I only use repetition to come out to our level. So that is when a certain condition we run, we iterate. When we don't know, we use the while loop, but when we know, we use for loop. So now in that case, firstly we are discussing about while loop, not nested loop. Now let's quickly look at while loop, and I'm going to use the for loop and while loop to declare the same thing, to write the same function and to produce the same result. So whenever you want to use your while loop, this is how you set it. You need to state the data type. What type of data type? Is it an int or is it an integer known as int, or character known as char, or a float or double? So it's left over to you, but what I'll be dealing with is character. So this data type, this is what I mean by your data type, which I have stated. Then I need to give it a variable name. So the variable name, I want to print lowercase character. So let me use lower as my variable name. Then I initialize it. What I mean by initialization is your equal sign equals to, then equals to your A, and I terminate it. That is my starting point. The starting point of my iteration should start from A, which is the first letter in our alphabet. Now, having set this, having what declared my variable by initializing it and assigning values to it, therefore I need to set a condition. Y is an English grammar. Y the lower is less than or equals to Z. Less than or equals to Z. So what we mean by what? Y this A, when you put A here, is less than Z, then you should do something. You should put char. We could use put char, we could use printf. But I want to use put char because that is what we are trained of, or what we are trained to be, the organization we are working with. So to put char what? Put char the lower, and you terminate this. So and character will only print, this put char will only print what? One character at a time. It will print one character at a time. So that we're trained with in the organization we're working to always use put char, and put char can only print one character at a time. So this is a condition that we have set. We want this looping to start from A. If A, you will put A here, is less than Z, then it's going to print A. And we need to set our what? Increments. You need to increment it. All these things I explained in that YouTube video, in our YouTube on the channel. What we mean by this increment? Just go and watch it. You will understand all these things. You will understand them. So that what? You should increment it if having what? After it has printed this, then we now increment. That is to increase, move away from A, move to the next letter, which is B. We now also put B here. While B is still less than Z, there's going to print B. And increase this one again. It's going to increase it from B to C. So, and put C here. While C is still less than Z, it's going to put just C and come here again, increase it. So this is what we call what? Iteration. We call it iteration. All this process, we call it what? Iteration. So now, let's quickly run this and see what it's going to print out for us. I'm using Lauren to save the name. Now, it printed what? 8 to Z. Note that it printed it immediately. The first thing it printed was A. It will now come here again, increase from A, move to B. If B is still less than Z, then it will print B. Now, it will continue to move like that until Z here. We know Z is not equal to Z. Z is not equal to Z, but Z is not less than Z, but Z is equal to Z. So in as much as Z is equal to Z, it's going to print that Z and try to increase again from Z to the next number, which is 27. So, and there is nothing to print again as much as what is equal to Z. Then he has printed it, then it terminates from the looping. It terminates completely and it stop, because we have set this condition to stop at Z. We may also set it that we want it to stop at M. We want it to stop at M, and we want it to start from from M, and we want it to start from, let's say, E. We want it to start from E and end at M. So let's run it and see what it's going to give us. It's going to give us the starting point of E and the end point of E. So look at this now. Look at this. We have it. We have set the starting point to be E and the what? The end point to be what? M. And the end point will be M. So, and we have it. The starting point E, the end point M. So that is how this thing works when it comes to while loop. Now we have set the while loop, which it has done the work for us. So I'm returning this back to the A, to start from A and to end at Z. Now, nested loop. It is a loop inside loop. A loop inside loop. If I'm also to use a nested loop now, then I need to declare another variable. And the variable I want to declare, I'm going to declare integer, but let me do the arrangement so that it can be in order, because I want this to repeat itself, let's say 10 times. I want it to repeat itself 10 times. So let me make it int I, or okay, int I. So I terminate it, but like I said, I need to rearrange this. So let me delete it and reset the condition. So you know how while loop work. So let me, so that this will not confuse us. Let me also so the first thing I need to declare is my int, because I want it to repeat for 10 times. In as much as it is an integer I'm dealing with to repeat itself 10 times, the data type I'm going to declare is going to be an integer, and it, not a char. So which I also want to put it a value. I want it to start from 1. And to repeat itself 10 times. So how will it repeat itself 10 times? We are going to look at that. So we declare the starting point, then your character. Let me also use lower here. Then when it comes to while loop, and that is when it comes to nested while loop, you don't initialize your second variable or your second definition. You don't initialize it. You only initialize it in the what? In the while loop. So I have used while loop the other time. Well, let me still use while loop. Let's just get familiar with one, whichever one. So while now I'm setting this, know as the what? This is your outer loop. While I is less than or equals to, so we want it to print 10 times. So we want to make it what? To print less than or equals to 10. Then it should do something for us. It should put char I. Sorry, put char what? We want it to print char what? New line. So that this will generate what? 10 times for us. It will generate 10 times. So having done that, we also what? Increment I. So having done that, then inside, this is outer loop. Then we want to declare the inner loop now. We now set another while loop. So make it to be what? Nested. Nest. After this one, the next one. Nested inside the outer loop. So this one is the inner loop now. So, and before we can set this condition, we need to what? Initialize this. What will be the starting point? So we now call our lower here equals to, so we make it A, then you terminate it. So while lower is less than or equals to Z, you will now come here again. You put the what you want it to put char. You want it to put char your lower, then you terminate and you increment your lower. So with this now, it's going to print 10 times. This will print. Now this is how this thing works. It's going to test this condition. Okay, your integer here I is 1. Your character here is lower. Okay, why I? What is your I? Is 1. When it is 1, so less than or equals to 10. Okay, 1 is less than or equals to 10. If this condition is true, then it will now enter the body of the loop. It will now enter the body of the loop. We enter the body of the loop, but also consider this. Okay, lower is A. Now, while lower, which is A, is less than Z, there's going to put char this lower, increase this, and it's going to print what? The new line. It's going to print what? Now, after he has what? Completed this iteration. How many times? 26 times. After it has completed this 26 times by printing A to Z, it will now come here. It will now come out from this inner loop and enter here. It will now generate a new line. After it generated another line, which is new line, it will come here. It's going to increase it from 1 to 2. Okay, it's still what? 2 is still less than 10. If that condition is true, it will enter here. You know, you're also what? Then it has increased to B. Then repeat this condition, continue to print A to Z until that one has been satisfied. We now come here again for the third new line. So that's how it works. So let's run it and see. So we have it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It produces what? 10 times. And still give us what? This new line. So this is how while loop and nested while loop works. This is how they work. So we've covered this, what are nested loop and how to use them. Now we want to move to function. What is function and how do you use function? So we are moving to function. What is a function? A function is a group of statements that perform a task together. It's together perform a task. So function does not have to do with one statement. It's a group of statements that are solving just one particular task. Now, every function in C language must have at least one main function. At least one main function. And this is the main function. Without this function, let me remove this. Let me try to comment it out. And let us see if this program will run. Let's see. Will it run? Without having that, can you see it's pointing this red? So there is no way when you don't have your main function, at least one function, which we know by default is usually what the main function known as the entry point. Without it, there is no way your program is going to run because it is the starting point and entrance to your program. So it has to be there. It must be there. So that is what we are trying to pass across here. And now you can as well have more than one function. When you have more than one function, how do you go about it? You need to separate it into a different file so that it can be easy for you to debug. Whenever you are having an error in your code, you're able to debug it easily. Is the excess of we what dividing our functions into separate file. And for your function, how do we what declare our function? We have what we call what function definition and function declaration. Now we are all used with this. This is int main. You have this. This is also a function. You are declaring this function. So which we know the syntax, which we have what? The body of the code. Then your code will go there. So this is what? Definition. But this one is a main function, and this is not what we are dealing with this morning. In this function that we have what? Return type. We have the word, the function name. And here is void. We are not passing any argument inside it. So we write what? Void. But when it comes to function declaration must have your what? Your return type, then it must have function name, then it must have parameter. That parameter is known as the argument. Parameter is your parameter, or you call it what? Argument. So either you call it parameter or you call it what? Argument. Then you terminate it. This is what we call what? Function declaration. Your function declaration must have your what? A return type. It must have function name, and it must have parameter or argument. And this will now depend, the type of argument you want to pass will determine on what you want to achieve. And your return type, whether it's going to have return type or void, is also depend on what you want to achieve. Also here, you may also have parameter, you may not pass parameter, depending on what you want to achieve. But the default is this. It will have return type, a function name, and your parameter or argument with this semicolon to terminate it. So this is what I call a function declaration. So our function declaration must have what? Function names, the return type, and parameters. So which we have done on us to what? Declare a function declaration. So to do that, you have your what? Your return type, your function name, and your parameter. That is, it could be void here if it's not returning any value, but here I expect it to return value since I've used integer here. So, and here will become an int. So this is my function name, which is what I want it to add two numbers, and these are the numbers. So this is called a placeholder. A placeholder known as what? Variable. So these are our variable. And what type of variable is this? Is an integer. Likewise here too, the variable here is also an integer. So when you are declaring your function, you terminate it with semicolon. So this is called function declaration. Now, when it now comes to function definition, your function definition, you call your function and and you don't terminate it, but you declare your what? Your function body, which your code will go here. Just like the main that we call the other time. So same thing is applicable. So this one is now called what? Function definition. Now we have what we called user defined function definition and the standard function definition. The standard function definition is this int main. Is this int main that has been defined in an header file known as the hash include stdio.h. It has been defined here. So if we are now making reference to it, we don't need to terminate it again. We just define what we are calling it for to do for us. We only define it what we want it to do for us. So we declare it here. So that is why we don't terminate it. We don't terminate it. Likewise here, if we have finished defining our function and we want to make reference to it by we calling it here, then we don't terminate it because it has already been defined in a particular source file, which we are going to look at later in our examples. And we're all familiar with it. Usually it was declared in our main.h file. So we now define what we want that function to do, the expression or whatever we want it to do. Then we put it here. So this is called function definition. Why? Let me repeat this. Why this is called function definition. Function declaration. Why this is function definition. So I want to repeat again what I mean by what? Function declaration. So like what we wrote here, this is function declaration. Function declaration. So I've commented this out. Now, function declaration, you are the one defining that function. You are defining it based on the problem you want to solve. With this type of function declaration now, I've defined it that, okay, I want this function to add two numbers for me. To add two numbers. And what are the numbers? Is num1 and num2 to add it for me. Therefore, I need to state what? The return type. What will be the return type of this addition of these two numbers? What I am expecting to throw back for me is an integer, because I'm expecting results at the end of what? Calling the function. I want you to return integer for me. Therefore, I need to state my integer here. Then I need to give it a function name. This function name can be any name. It can be your name. But it is advisable that the function name should be related to what you are defining or what problem you are solving. The problem I want to solve here is to add two numbers for me. Therefore, I've made use of my words to add, which is related to the problem I want to solve. Then, how many numbers did I want it to add? We now determine the number of parameters I want to pass. I want it to add two numbers. Therefore, I need to pass two parameters, which is what? Int num1 and int num2. If I want it to what? To add three numbers, I need to declare another parameter. That is int num3. Int num3. That is what? Three parameter. That means I want this thing to add three numbers. That is any three integers. Any three numbers to add it for me. So I need to terminate it here. With this now, I'm able to define this function. which I can always make reference to anytime I want this function. I can always make reference to it. And for me to make reference to it, I need to call it. Actually, I repeated what I have done here because I still need what? To tell this function what this function needs to do. I need to define it. After I declare it, I need to define what I want these functions to do. So, and for me to define it, I need to bring out this function, but I don't terminate it because when you terminate it, your compiler will assume that it ends here, that it stops here. Therefore, it won't be able to relate with this. Whatever code that you have here, the compiler will not take it together with this because it believes that this one has ended here. Therefore, this is a new beginning. Therefore, how do you want me to interpret whatever that I have here? How is this related to what you have here? In such a case, we'll be having what? Error. We'll be having error. So for us to avoid the error and for the compiler to see this as a continuous statement, therefore we don't terminate it here. So it is here now, we now determine what we want it to do. So that is now the emphasis now is how to declare your function declaration and how to define your function. This is function definition. So this one is called a function definition. So when you are talking of function definition, this is what they mean. So everything we've discussed here is what I've been written here. Function declaration and function definition. So in our function definition, it provides the actual body of the function. So this is the syntax which we have done. You have your return type, you have your function name, your parameter list, then the body of the function which we have done. So we move to the next one, which is the return type. Let's talk about return type parameters, though I've talked about it, but quickly we just summarize what we are having in this slide. So we've covered this aspect, what a function is, and we said at least our program must have one function, which we know by default is the main function. We've looked at function declaration, what it means. That your function declaration must have a function's name, it will have return type and parameters. Then you terminate it with semicolon. While function declaration will always provide the actual body of the code. So this is it. Now return type. Let's quickly look at a function definition in C program consists of a function header. It must have a header and a function body. That is function definition, which we've looked at. So here are all the parts of function. We have the fourth part, which is return type. We have discussed that a function may return a value. So the return type is the what? Is the data type of the value the function wants to return. It depends on what the function wants to return, and that will determine what? The type of data type. So some function perform the desired operations without returning a value. Like I said, some may return value, some may not return value. The code we run the other time, A to Z, does not return any value for us. It will only print out. Therefore, in such a case, the return type should be void in that condition. While function name, this is the actual name of the function. The function name and the parameter listed together signified what? The function signature. If you say you are writing a function and you don't have name and you don't pass parameter, then you are not yet writing a function. Now parameters is like a placeholder. So when your function is invoked, you will pass a value to the parameter. When you call your function, you have to pass a value to it. So these values is referred to as what? The actual parameter or argument. So the parameter list refers to the type, order, and number of parameters of function. So parameters are optional. Take notes. They are optional. That is, a function may contain no parameter. It may take no parameter. It depends on what you want to achieve. Then the function body. The function body contains a collection of statements that define what function has to do. What the function has to do. So let's move to the next one. Now, given below is the source code for a function called the max. That is maximum number. This function takes two parameters. It takes num1 and num2 and returns the maximum value between the two numbers. Now, this is a function returning the maximum value between two numbers. So actually I've explained this. This is what we call what? Function definition. Function definition. Because we declare this function here, we call it here, and we give it a body. So this is a body. Inside this body, we have local variable declaration, known as what? Int results. We expect this function to return a result for us. Therefore, we use what? Integer here. And is to what? To compare between two variables, num1 and num2, before it can actually print out the what? The maximum number. We are talking of, okay, we want to get the maximum number of a program, or the maximum number. We want to get maximum number. Therefore, we know we need to what? To declare, that is, what is it called? We need to compare between those two numbers. So since it is two numbers, therefore we pass two parameters, int num1 and int num2. We pass two parameters, num1 and num2, and whose data type is an int, because what we want to get is an integer. Then the local variable declaration, we are expecting results. We now compare. If the num1 is greater than num2, then it should return the num1 which is greater. Else, if this condition is not true, else then it should return what? Num2. That means num2 is greater than num1. So the return to result we expect is what? Return the result for us. The result, whether num1 or num2, is the essence of this result. Return results. So the emphasis here for now is what? Your function body, which we have done. Now, function declarations. We've also talked about this. We've talked about this, just an example, and this is it. That you have your return type, you have your function name, and parameter list. So this is your function declaration, which we've also looked at. It carries what? A semicolon to terminate it. Now, also take note of this. The parameter names are not important in function declaration. Only their type is required. I repeat, parameter names are not important in function. What do we mean by the parameter name? This num1 is a parameter name. Num2 is a parameter name. So they are not important in function declaration. Only their type is required. So if I still declare this way, int max int comma int is still acceptable, and I did not pass my num1 and num2. So this is still what? Acceptable, because the name is not as important as the data type. So anybody that wants to call this function now can now pass his own name to it. But with this now, we're able to know, okay, this function is to take what? Two integers, that is two parameters, is to take two parameters, and this maximum is to compare between those two parameters. So I can now just call it and pass my own name. So in as much as I have stated the what, the data type of the maximum number, or the max I want to what, to take. But if I did not set this data type, it will be a kind of confusion, because everybody that wants to call this functional will not know, except people, we can still just, okay, let me just guess. We can still guess, okay, since this one is a maximum number, then this should be an integer. But actually the emphasis is just that what, it's not necessary you put your name, the name of the parameters. It's not necessary as the data type. If you put the name of the parameters and you don't put data type, it's not acceptable, it's not allowed. So function declaration is required when you define a function in one source file and you call that function in another file. So now function declaration is usually required after you have defined a function in one source file, and you are now calling that function. Therefore you need to declare your function. In that case, you will need to declare the function at the top of the file that you are calling it. Let me quickly do the example of such. So for instance, let me still make use of this addition, the addition of this. Actually, we are meant to separate this file according to the organization we are working with, how we are being trained. But just the emphasis there that whenever you are calling a function, you need to declare, or the function declaration, you have to state it above the function you are calling. So you state it here. And if you consider the organization we are working with, we usually have this one in a separate file. When we have it in a separate file, known as what, main.h. So we make reference to that main.h here. Hash include, then the main.h. In this kind of situation, I don't need this again because it's already contained in this file. It's already contained, so therefore I just declare this header file, in which this function has been defined, or that has been declared, that has been declared. So I've made reference to it. Therefore, anywhere I see my hash include main.h, it also represents this. And in a situation where I'm not having this, I'm not having it, therefore I need to declare this at the top of this function I am calling. So it's the emphasis of what we are passing across here.